Mm-hmm.
So till where we have completed, I think so.
Mm-hmm.
Yes, we have seen 2.1. We have seen how to calculate the percentiles and standardized score, Z score. And you know, the p percentile of a distribution is the value with p% of the
Mm-hmm.
observation less than or equal to n. Okay, Z score is
Mm-hmm.
value minus mean upon standard deviation, means the data point minus the mean of the data upon the standard deviation of the data. The next important was the cumulative relative frequency. Yes, cumulative relative
Mm-hmm.
frequency, and we have seen. I'll open my board first of all. Okay, so I'll say this. So we have seen how to calculate the cumulative frequency. For data, we know if there is a table where there are entries 1, 2, 7, 1, 10, 12. So what do we do in cumulative frequency when we are calculating it from upside? We generally write the first entry as it is, that's 1. Then we go on adding with this, the total of from here, we add with this, means 1 plus 2. We only like to have, right, we only need to write the addition 3. So what I'll do in this, I'll write the addition 3, then 3 plus 7 is 10, 10 plus 1 is 11, 11 plus 1 is 21, and 21 plus 12 is 32. So this is our cumulative frequency, CF, which is called. And relative, you know what to do in relative cumulative frequency. We just have to take the figure of the cumulative frequency divided by the total. So total, I think it's 2, 3, 4, 4, 3, 7, 8, 8, and 1, 2, 1, 2, 4, 78 divided by 78. So this was the relative cumulative function. That's for revision that we have covered. So it is necessary to transform the data when changing units of measurement. Yes, transform data. We have seen one example how to transform the data. Means we have to bring them into z-score, and also z-score we have seen in transform data when we add or subtract. When we add or subtract a constant from all the data points, from all the data points. So what is the conclusion is that the IQR, the median, and the range, which are the measures of variability, and the range, all these three is the measure of variability. Measure of variability. This does not change. This does not change. This does not change. Does not change. But but all the other factors, but all the other factors such as the minimum, the maximum, the mean, or what was else more, I think minimum, maximum, mean, standard deviation, all increase if we are adding, they increase, and if we are subtracting, the decrease by that by that constant value. That was the summary. And if we multiply, you can see that When you multiply, divide all the values in a data set by a positive constant, measures of central location and variability are multiplied by b. And when we multiply, 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 or divide the whole data, then all the parameters or statistics you can say, then all the parameters, if it is a population, parameters, or we can say statistic it is, statistic changes by the number which we have multiplied, changes the number which we have multiplied or divided, which we have multiplied or divide with, or divide with. That's the thing. You got it, Zaid? The thing that we have done just for revision because it was important. Okay. So this was the exercise. Okay. Density curves and normal distribution. It's very important. The important topic is, this is one of the most important topic, density curves. Density curves and normal distribution. So first of all, we'll see what are density curves. Okay, so learning targets. By the end of this section, you should be able to use a density curve to model a distribution of quantitative data. Identify the locations of the mean and median of a distribution from a density curve. Use the empirical rule to estimate the proportion value in a specified interval, or the value that corresponds to a given percentile in a normal distribution. Find the proportion of values in a specified interval. That's all. We'll read it further. We'll see it here. Okay. So what's a density curve? Okay. Selena works at a bookstore in a Denver International Airport. She takes the airport train from the main terminal to get to work each day. The airport just opened a new walkway that would allow Selena to get from the main terminal to the bookstore in 4 minutes. She wonder if it will faster to walk or take the train to work. Figures 2.7a shows a dot plot of the amount of time it has taken Selena to get the bookstore by train each day. For the last 1,000 days she worked. To estimate the percent of days on which it would be quicker for her to take the train, could find the percent of dots that represent journey time less than 4 minutes. Surely there is a simpler way than counting all the dots. So 2.7b shows the dot plot model with a density curve. You might wonder why the density curve is drawn at the height of 1 by 3. That's so the area under the density curve between 2 minutes and 5 minutes is equals to 3 into 1 by 3, which is equals to 1, which is equals to 1%. We'll see. Okay, see. This is the density curve. This is the density curve. So what do we generally do? Density curve. It is same as the dot plot. Nothing different. I'll take this.
Uh, like, can I go to the bathroom real quick?
Yes, you can. Yes, yes. I'll also drink some water.
I'm back.
Okay, so you're coming back to the topic. Okay.
Mm-hmm.
So what he has done, literally, he has plotted a dot plot. He has plotted a dot plot, correct? Now,
Mm-hmm. Yes.
yes. So what he has done, the dot plot is between the height 1 by 3. Okay, 1 by 3. So what he has done, when we need to, what do you say, plot the density curve, what we do generally is that we go like this, then like this, then it will go like this
Mm-hmm.
and like this. But the estimated line, the line that is what you say, same from the remaining points, is that most of the points lie between. It's like this because see, you can see here, the maximum of the point is lying here. Yes or no?
Mm-hmm.
So we generally plot this one, or the density curve generally look like this because there are some points here, then it increases, then it increases, then again it increases, and then again it decreases. But what is the case here? The case here is that it is crowded at a one region, so no need to. We can do like this also, but the density curve that will come because here the space has been leaving. So what we'll do, draw this line. So this is the density curve, means below this all the points, maximum points lie. See, this is the density curve in which he has drawn. Understood, Zaid? We'll see how to plot it and how more examples, so it will be more clear, inshallah.
Yeah.
Okay. So dot plot of Selena's travel over. Oh, he has given something here. It was given. Shows the dot plot model with a density curve. You might wonder why the density curve is drawn at a height of 1 by 3. That's so the area under the density curve between 2 minutes and 5 minutes equals to 100%. Okay. So when we from year to year, he is telling that when we draw a line, when we draw this line, so the data points will be 100%. The calculation of it will be 100%, means maximum points will lie inside it. Maximum points lie inside it. Lie inside it. We generally don't use a line format. We just draw this curve and end that. If minimum points are leaving behind, no problem. Okay. Okay. So, dot plot of Serena time travel over the past several years. We are trained from Denver Airport main terminal to the bookstore where she works. The red dots indicate times when it took her less than 4 minutes to get to work. The red plot shows us the time where he took less than 4 minutes to get to work. Density model, the dot plot in part A. The red aided shaded area estimates the proportion of time that took Serena less than 4 minutes get to work. So this is the area where she got less than 4 minutes, taken less than 4 minutes, and this was the area where she took between 4 to 5 minutes. Okay, so this was the dot plot that we have plotted, that we have taken. The table will look something like this. Selena work for Selena time to work, Selena time for getting to work, Selena time getting to work, get to work. So there are 1,000 observations, 1,000 observations. So what will be? Sometimes he got into work in 2.3, 2.2, 3.5. It would be 5.6. So this is the dot plot which has been plotted here. Okay. So now how to density curve? A density model distribution of a quantity data with a curve that is always on or above the horizontal axis, has exactly one underneath it, means underneath it means it has, and I'll explain the points here. I'll take that table. This is very important. So the density curve model, the distribution of a quantity data with a curve, it is always on above the horizontal axis. This is the horizontal axis. The density curve is always or about. It can be a line. It is generally plotted via the points which are lying below. It can be a left skewed curve. skewed to the left or a right skewed to the right curve. It can be any, but it is a curve, general curve. Okay, it can be like this
Mm-hmm.
also. This curves also. Yes, has a area
Mm-hmm.
exactly one underneath. Means what? Has area exactly one underneath means when there is a range to range. Then when we draw a curve means 100% of the possibility, 100% of the data, 100% of the data must lie underneath, must lie inside it, must lie inside it. Okay. The area under the curve and above any internal of values on the horizontal axis estimate the proportion of all the observations that fall in that interval. Means if we take a part of this, so we'll get the proportion, of the data behind it. Okay. So the red shaded area under the density curve in figure 2.7b provides a good approximation for the proportion of percentage of red dots. So if we need to find the percentage of red dots, what we need to do? We need to calculate the area equals to base into height. See here, see here. If I want to calculate how much of the data is lying between 2 and 4. So between 2 to 4, between 2 to 5 it is, but I want to find the area between 2 to 4. So what is the base? The base is around 2. Yes. And what's the height? It
Mm-hmm.
was around 1 by 3, correct? For the density curve. So how much area is lying between 2 to 4? How much percentage of data point is lying between 2 to 4? Okay. So what I'll do, area equals to base into height. The base is 2 and the height is 1 by 3. So it will be 2 by 3, which is 0.666. So means 66% of the data lies between 2 to 4. 66% of the data lies between 2 to 4. See, we'll see. There, here, here. See, he has approximated it. It is. Did you got that, Zaid? Are you there, Zaid?
Yeah, I said yes, yes.
So this was the thing that density curves tells us. Now moving on to the next topic. That's so random. Example density curves. Okay. No quantitative data is described is exactly the density curve. The curve is an absorbent. See, the curve is an approximation that is easily used to accurate the enough in most cases. The density curve simply smooths out the irregularities in the distribution. Means what? I've told you here. In this case, what there were many of the data points which were above the line. But what do we do?
Mm-hmm.
Leave these data points and approximately make the curve such that maximum points lie between it because no space should come in it.
Mm-hmm.
Okay, so read these questions, eh? Come on, fast.
Okay.
Yeah, I'll read it once.
Okay.
Okay, so what he is telling that is that see, suppose you use a calculator or computer, a random number generator to produce a number between 0 and 1. Okay, the random
Mm-hmm.
number generator will spread its output uniformly across the entire interval. So, see, suppose we are recording what this random number is generating. So it is 0, 1 and 2. So for suppose it is generating 0, he has generated 0, so my data the thing will come here. This it is coming 0.0001. Then there are different points in that. Okay, he has told that the points generated are equally likely, means it is a uniform distribution. Uniform distribution means every point will generate the same number of outputs that we are using. So something like the data will be like this. So the random number generator will spread its output uniformly. Uniformly means equally for every interval across the
Mm-hmm.
interval from 0 to 1. For every data point between 0 to 1, the output for any one data point will be the same for each and every data point case. So draw a density
Mm-hmm.
curve to model this distribution of random numbers. Be sure to include the scales on both axes. So we need to include the scale on both axes. So here on the x-axis comes the random number that we are recording, random. number, and here is the height. The second thing is the height. So HEIGS height. Okay, so what he has done? Okay, so we'll take the height as half. Okay, for suppose the height is as half. He has taken here. So for suppose I'll complete the data point. Why we have taken height half? Because area. What must be the area, Zaid? 1? Yes or no? Area must be 1. So what the area formula is base into height. So base,
Mm-hmm.
what's the base? Base is around, I think, 2 into height. Yes or no? So
Yeah.
height will be the that this 2 is in multiplication here. It will go on to this side, will go into division. So it will be 1 by 2. So height is half. Did you got that? How to calculate the height?
Mm-hmm.
Yes. So this is the perfect means this is not something that is very neat, but this is a perfect what you say the density curve that we can draw. I'll name it again. That
Mm-hmm.
will be more clear. So this is height, which is around half. This is the correct data that we have marked with us. Density curve. Did you got that, Zaid?
Yes.
Okay. So this was the data that we had plotted. Okay. We just need to just I have drawn this was the line density curve. We don't need to draw this dot plot here in the density curve. So what I'll do, I'll draw one more case. Just it was for explanation. So it will be 0 to 2. The height I have calculated as half. So what I'll do, take the scale half here. Correct, half. The scale that you are taking on the x-axis must be the same scale that you are taking on the y-axis as well. So height equals to half. So this, the height where it is coming half, this will be the density curve. This is the density curve. There are no dot plots between here. This figure represents the density curve. Okay. Okay. So what is the next thing is that about what percent of the randomly generated numbers will fall between 0.87 and 1.55? That's a good question. 0.87 and 1.5. 0.87 and 1.55. So we need to calculate the percentage of numbers that is falling between 0.87 and 1.55. 0.87 will be something here as 0.87 and 1.55 will be something here. So 1.55. So what is the base here between 0.87? How we will calculate the distance? How you will find the distance means greater quantity,
Standard
greater
deviation.
quantity minus
The
smaller quantity. So it will be 1.55 minus 0.87. So I think it will be 5, 0, 15, 14, 15. It will be 8, 6.0, 0.68. So my base is 0.68. So what he has done, we'll see here. He has
Probably the
calculated the
Niji
base
model.
into the
Okay.
height. So area will be, we need to calculate the percentage. The area gives us the percentage. So it is base 0.68 into height. That's 1.2. So it is around 0.34 means 34% of the data lies between 34%. I'll write the conclusion here. 34% of the data lies
Mm-hmm.
between 0.87 and 1.55. Did you got that? How to calculate that, Zaid?
Yes.
So
Mm-hmm.
next is the same sum as it is, but we are calculating reverse wise. Okay, we'll see the third also. Estimate the 65th percentile of this distribution of random numbers. So this, see this 65th percentile. So what 65th percentile? 65th percentile is the area. If we go, where's my pen, man? It's not working. So 65th percentile we have to find. What's the question? I'll estimate the 65th percentile of this distribution of a random number. So what will be the data point? The range between which 65th percentile of data will lie. Means we'll start
Mm-hmm.
from here, from 0. So what will be the range? From here to how much it will be the range? Such that the 65th percentile will come. So we need 2 points to calculate the base. So we need 1 point as we'll take as x. So what will be the
Mm-hmm.
base? Base will be 65th percentile means area equals to 0.65. Yes or no? Because
Yeah.
65th percentile gives 65% of data below or equal to it. So it is 0.65. Base is upper minus lower. So it was starting was 0 and the ending where we need to calculate is x. So base is x minus 0 and the height is height is 1
Half.
by 2, 1 by 2 half. Okay. So we need to put it in area equals to base into height. So x minus 0 is
Mm-hmm.
x. So area equals to 0.65 equals to base. Means x into height, that's half. So this will move on to here. So it will go into multiplication. So x equals to 0.65 into 2. So that's x equals to 0, 1, 13, 3, 1, 1.3. So x equals to 1.3. So 65th percentile of data 65th percentile of data lies between, this will be somewhat 1.3. So 65% of data lies between 0 to 1.3. 65% data. 65% data. Okay. That
Mm-hmm.
was conclusion. This is the things that, okay. Now, what is going? Just a minute. I'll clean my keyboard. It's
Understandable. Okay.
okay. Describing density curves. So we are now what I describing means. I'll write it down. Describing density curves. Describing density curves. So what is generally a density curve? What we need to do? When we had drawn a density curve, it can be, I told you, any shape. So describing means estimating or what you say, removing, removing various parameters or statistics, various parameters or stat from that,
Mm-hmm.
for a stat from the density curve. That's known as describing density curve. Where is exactly mean, median, mean, median? We have not studied mode till now. Okay,
Mean and median is gonna. The mean is always in the center.
always in the center.
The
Yes,
median, the median determined by the um where the highest quantity of dots are,
correct. So we'll
and that's it.
yes. So density curves come in many shapes. As with the distribution of a quantitative variable, we start by looking for a rough symmetry or clear skewness. Then we identify any clear peaks, show the three density curves with distinct shapes. So this is the skewed to the left, but this is unimodel, one with one mode. This is roughly symmetric bimodel, and this is skewed to the right, again unimodel with one yes mode.
Mm-hmm.
Okay, okay. One more thing, the density curve that we had drawn here. Was this which type? Was it unimodel or bimodel?
Or
It was a yes?
uh, I think that was unimodel.
No, no. This data where there has no peak, where the data has no peak, has no peak in it. So it means the data does not has mode. There is a case. It means that data, please,
Not any mode.
does not yes, does not have mode. Does not have mode.
Okay, that
Okay.
seems understandable.
That is understandable. Yes. Okay. Density curves with different shapes, so it cannot be inclined. Our measures of central and variability apply to the density curves as well as to the distribution of quantitative data. Recall that mean is the balance point of a distribution. Illustrate this idea for the mean of a density curve. So the median of a distribution of a quantitative data is a point with half the observation of either side. Correct. Median is exactly, I have told you, at the half where it is. So here what he is telling you is that if the data is left skewed, right, skewed to the right. So where will the mean shift? It will shift to the right generally. But it is the balancing
Yes.
point of both. We cannot generally take exactly to the left or exactly to the right, but it is the balancing point of both. So we'll see when we are, see how it's described in the data. It is shown by some pointer. It can be any pointer. Here he has used a red triangle where the mean is exactly there. The median of a distribution of a quantity data is a point, yes, where exactly the half points, I've told you first only. The half points, for example, for this is that the data where 50% of data is on the left and 50% of data is on the right. So median is, I think, very easy to calculate in a density curve. So median of a density curve and mean of a density curve and median of a density curve. So median of the density curve is a point at which the curve would balance if made of a solid material. Means, have you studied physics, right?
No, and pre-talk.
No, you have not said. So there is something center of mass. Center of mass. You have seen this
I
that
said hello.
there is a video on YouTube. So I'll explain you what's correctly the mean is. There's a video on YouTube. If I put 3 to 4 dumbbells, this is a bar, weight bar. Okay, if I put 3 to 4 weights here, and if I put one weight only here, will it be possible to pick up this bar from the center with one hand? Just go
No,
and do this experiment. It won't be possible to pick up the bar from the center with one hand. What we have to do, we have to use the law of physics that we need to shift
and
our
pick it
hand
up at the shift
towards.
of the left side.
Correct. Center, what you say, center of mass, where the mass of actual body is concentrated. So we need to shift our hand to the left because more weight is concentrated towards the left. And where exactly the mass is concentrated, that's called as the mean. You got that? What I'm trying to
Mm-hmm.
explain you? Yes, that's the thing.
Yeah.
So median is very simple. The median of the density curves is the equal area points. I've told you first only. Equal area points. Let the curve will be anything. So there's a point where equally the points lie. Exactly equally the points lie. Half on either side. Equal half. A symmetric density curve balances at median midpoint because of two sides are identical. So when there is a symmetric density curve, symmetric means roughly symmetric, or it can be ideally symmetric also. So mean and median of a symmetric density curves are equal. So if we'll come to it, it is also known as a Gaussian normal or normal distribution where there is a symmetric curve. So the mean and the median is exactly at the center and mean is equals to median. Remember this.
Mm-hmm.
Median. Where is this condition? When for symmetric curves. Symmetric curves. That's the thing. Okay. So that was the case for symmetric curves. Okay. So see how it is showing. We use technology to locate the median in the figure 2.10. The mean is greater than the median because balance point of the distribution is pulled towards the long right tail. I have explained you first, right? Yes or no? If it is right skewed, skewed to the, let it be right skewed. Huh? Okay. It is right skewed. Okay. So if, for
Median will
example,
be shifted to the center,
median
and the mean will,
median will be here, and where will be the mean?
and the mean will be in the center of everything.
Center, not Z.
No, no, no. I meant the center of the line.
Here,
Yeah.
yeah, because it is right skewed, so the mean will be towards the right of the median. It cannot be equal. Mean and median cannot be equal here because it is right skewed. So there is a greater value at the right. I've given you example in the earlier classes. How does it shift towards the right? So it will go. We have seen when the data, when the output was 2.22, and when we had added 100 in the data means we had added an outlier to the right side, so it became 7.15. How mean shifted towards the right, but the median remains 3 only in both the cases. So suppose this is 3 and this was the mean before this, I think. So near about it being 3.22, bring this 3.22. So for example, 3.22 is the mean before. But what happened when we added a 0.100? So it shifted towards the right. So this is the mean. See, he is showing median and mean for a symmetric distribution. And this green line is for median and this red dot is for mean. This is how you describe the mean and median in the distribution. Are you getting that, Zaid?
Yes.
What does the left skew do? Now, mean versus median. I'll show you that also. We have discussed this earlier only. That's the reason I teach the things earlier. Okay, so for example, this is median, median, median. This is median. So where will it be the mean to, as it is left skewed? Whether it will be to the left of the median or to the right of the median?
The
Come on,
me
Zaid. I'm expecting answer from you. The mean will be
Wait,
from
the median, and if it's in the center, then the median and the mean will be the exact same point.
correct, but it is left skewed and the median is for suppose here, not in the center. You are getting confused with the center, I think. For suppose it is
The
towards the left. Okay, there is a median. So where will be the mean? Towards the left of the median or towards the right of the median? This is not a symmetric distribution. It is
right?
skewed to left, skewed to left. So the mean will shift towards the left. Mean will shift towards the left because there will be a mean. So
Yeah.
here mean is less than median. Mean is less than median. In the previous case, I think that I need to give you an example in the next class. So you see here, this was the mean. It has shifted towards the right because an outlier was towards the right. Here, the outlier is towards the left, towards the left. So the mean has shifted towards the left. And if you are what you are saying is for a symmetric distribution where the curve is exactly same from both the sides. So the median and mean is at the center. So mean and median both are at the center. Means both are, we can say they are equal. Got that? See, now this is the thing. The density curve that models a distribution. A quantitative data is shown here. Identify the location of the mean and median by letter. Justify your answer. This is very simple. This distribution is left skewed. Yes or no?
Mm-hmm.
Left skewed. Okay. So the extreme left point. I think I want to take this. So see, there are 3 points. This, this, and this. Now, when there is skewed to left, the mean is extreme line. That's to the left. That's to the left. So because it is left skewed, so the line with a point, that's to the maximum to the left, so it will be mean. Correct. The median will be towards the right, so this will be the median. That's in the center. That's the thing. Did you got that, Zaid?
Mm-hmm.
That was the thing. Okay. Why we have taken B as the median? Because it was cutting equal areas. Because it was cutting equal areas on both the sides. That was the thing. If would we have taken C, C is the exact center of the curve, means the exact center of the peak. But it is left skewed, so there wouldn't be equal areas on both the sides. If I would have taken this point, so there wouldn't be equal areas on both the sides. Yes or no? It is looking from the figure only clearly. That's the thing. Even though C is directly under the peak of the curve, more than half of the area is to the left, so C cannot be the median. I have told you this, explained you this. Okay,
Mm-hmm.
so that's normal distribution. So it's a very good topic, normal distribution. I think we shall start it tomorrow. Okay,
All right. Got it.
so thus we'll discuss two things of a normal distribution. Normal distribution. Just we'll discuss normal distribution here. What's a normal distribution? Generally, normal distribution possesses normal curve. Normal curve means bell curve. Bell curve.
Not the right skewed or left skewed, then in the
Correct.
center.
Correct. It is not skewed to right nor not skewed to either not skewed to right nor skewed to left, but
Left.
but it is exactly, exactly symmetric, symmetric at the center. And every, I'll write one more thing, every population patient possesses population data possesses normal distribution. Whenever we are taking a population data, it will possess normal distribution. Therefore, we are not studying the different distributions, Poisson's, Bernoulli, binomial. We are not studying that distribution. Why? Because in statistics, in data science also, this is the main distribution that is under study. That's the called the normal
Yes.
distribution. Okay, so we
Yes.
can see here there are different graphs. I'll explain you everything tomorrow.
Highest peak is in the center.
Yes, highest peak is in the center, and it has exact the bell. Is the curve of the distribution of the data points is exactly as the bell.
Mm-hmm.
The tail to I'll be not be exactly correct in drawing, but I possess that I am exactly correct because I'm explaining you. So the tails towards the left as well as the right are of equal measurement. So therefore, it is an exact bell curve. It has two parameters generally. Two parameters. One is I've told you normal distribution possesses population parameters because every population data possesses normal distribution. Yes or no? So the
Mm-hmm.
parameters for normal distribution is mu and sigma square. Mu and sigma square. Mu,
Mm-hmm.
it's for mean, population mean, and sigma square is for variance. Var. So what's the thing? I'll tell you here. When we draw this peak, this peak gives us the mu, correct? And
Mm-hmm.
and and when we draw this peak, then the first standard deviation, the value of sigma, this is sigma. When we calculate, we go, this is for suppose mean, and when we add some sigma, then we get the first standard deviation, mu plus sigma. When we add one more sigma, so we get mu plus 2 sigma, and we'll add one more sigma, so this point will be mu plus 3 sigma, means we have added 3 sigma. And if we subtract mu minus sigma, this will be the first point, mu minus sigma, this will be the second point, mu minus 2 sigma, and this will be the third point, mu minus 3 sigma. So
Yep.
from year to year, 99.7% of the data lies here. 99.7%. All the data points. I'm talking in percentage.
Yep.
Means there are exactly, or you can say minutely, either 1 or 2 points that are outside this. But between this, 99.7% of the data lies here. Did you got that, Zaid?
Mm-hmm.
I'll explain you tomorrow.
Yeah, and within the two sigma, there's 95%, and
Correct. Between 2
in
sigma,
between one
here
sigma, there's 68%.
67 or 68%. Between here, it's 95%. Between 2 sigma, 95%. And between
Mm-hmm.
first sigma, this is the case this year, it is 67 to 68%. That's the thing. You know that. That's good of
Mm-hmm.
you. Okay, so I
Yeah.
think we shall start this topic tomorrow. You just revise
Mm-hmm.
it, what you know about it, normal curve and all. For suppose I have
Mm-hmm.
explained you all the thing of the normal curve. That was very simple. Normal, and I don't think there's much. Then the empirical rule is there, so the empirical rule you can learn that also. Was the empirical rule?
Mm-hmm.
See here, that's the 68% of the data lies between the first
Between
standard
95,
and
99,
95 and then
99.7%.
99.7%. And there is some possibility, because we are talking about all the normal distribution, so there is some possibility that some data may lie between this interval as well as this interval. That's called as
Mm-hmm.
also called as the rejection ratio. When we'll study hypothesis, we'll study what is rejection ratio and all. See the first
When
sigma.
it's below, if it's below 3% or it's below 0.05%
Correct.
in
We reject it.
95, then we have to reject the null
Correct.
hypothesis.
It's not. Yes, that's good. See, this was all the things that we'll discuss tomorrow, inshallah.
Mm-hmm.
Finding area in a normal distribution. Yes, we can find area. We know how to find the area. We have seen for a density curve which was very having a straight line, but here it is a curve, so we can find it exactly knowing the height and all. Then comes again
Yeah,
the
okay.
standard normal distribution. If we subtract the value minus mean upon standard deviation, then it's known as standard normal distribution. Means if we are plotting all the values with standardized data, I'll explain you this tomorrow. So the standardized data, then it is known as standard normal distribution. And for standard normal distribution, SND, the mean is 0 and the standard deviation is 1. That's the thing for
Mm-hmm.
standard normal. I just want to see how much is big is the standard normal. Then there are different sums. Any other topic here? We'll just see and we'll stop it. Okay. So this is standard normal. How let's normalize the probability plot. We'll see that how normal distribution also possesses a probability plot. Oh, I think 2.2 is there and 2.3 is not there. I hope so. Uh,
Nope.
that's chapter 2 wrap. Yes, yes. Means normal distribution is the last thing of this chapter. So we'll require generally one lecture, one or two, couple of lectures to finish this. Then we'll finish with unit 1. Alhamdulillah. Then we'll move on to
Mm-hmm.
unit 2. Okay,
Yep.
that's done for today, Zaid. Study hard, study with more enthusiasm. Okay. Assalamu alaikum wa
Mm-hmm.
rahmatullah. Allah Hafiz.
Assalamu alaikum.